Okay, so in this video I'm going to have a quick look at radians. I'm going to introduce radians and I'm going to have a look at the sine, cos and tan of various basic angles using radians and degrees in fact, and we'll have a look at the unit circle as well. So first of all I'm just going to have a look at radians here. I'm just going to have a look at what a radian is exactly. So if we take a circle, let's see, we'll just draw a circle here, and we take a diameter of the circle here. This is our diameter, and the distance around the circle here is called the circumference. And if you divide the diameter into the length of the diameter into the length of the circumference, you get pi. So if you divide the length of the circumference by the diameter, you're going to get pi. That's where pi comes from. And that's going to be roughly around 3.14. So there are roughly 3.14 diameters in the circumference of a circle. Now, your diameter is just going to be, it's going to be 2 radii. So that's a radius there and a radius there. So a diameter is just twice the radius. So if you multiply across here, you get the circumference being the radius times 2 pi. So if we take the circle again and we just have a look at a radius, if you take the distance, the length of the radius from here to here, and you measure that distance around the circle here, it'll be roughly, say, here. So in other words, this distance here will be the same as this distance here, from here to here. So roughly from there to there is the same distance as your radius. Well, then this thing here, this angle here, is called 1 radian. So that's how we determine what a radian is. So we just measure the length of our radius, measure it along the circumference, and the angle that it makes is called 1 radian. Now we know that the entire circumference is going to be the radius times 2 pi. In other words, the entire circumference is 2 pi times the length of the radius. There are 2 pi radii in the entire circle. So in other words, what we're really saying there is that there are roughly just over 6 of these angles, in other words 2 pi, 2 times 3.14 if you like, of these angles in the entire circle. So the entire 360 degrees here is just over 6 of these angles here, or 2 pi of these angles here. So in other words, if you take your well, I'll just do that again. So what I'm going to do is just draw the x and y axis here. So if you take this here as being 0 degrees, the entire circle here, all the way around here, is going to be 2 pi in terms of radians. So this is the angle, the entire 360 degrees, the entire 360 degrees back around to 0 again will be 2 pi in radians. So a radian is just another way of measuring angles. So if we have a look at that again, if we take our x and y axis here again, we've got 0 degrees if you like, or 2 pi if we go all the way around. Halfway around then is going to be called pi. So from here to here is going to be called pi. This angle here, straight angle, or 180 degrees, is pi. 90 degrees here is going to be pi over 2, or just half this angle here. This angle here, 3/4 the way around, is going to be 1.5 pi. From here to here is 1 pi, so we go another half. So that's going to be 3 over 2 pi. And then back around again, that's going to be 2 pi here. So our 90 degree angle is pi over 2. 180 degrees is pi. 270 degrees, 3/4 the way around, is 1.5 pi, or 3 over 2 pi. And the whole way around then is just going to be 2 pi. So that's how we measure these four basic angles here. Now, what about other angles? I'm going to talk about 2 other angles, and they're going to be 60 degrees and 30 degrees. What are they in terms of radians? Well, let's have a look at that. If you take, let's say 30 degrees. 30 degrees, okay. So 30 degrees, how many 30 degrees are there in 360 degrees? Well, you'll find that there are 12. There are 12 of these in 360 degrees. So we'd have to multiply 30 by 12 to give us 360 degrees. So in other words, 2 pi is our 360 degrees. So 30 degrees, which will be, you know, something like roughly around here, say that's our 30 degrees there. There are 12 of those, so divide 2 pi by 12 and we'll get pi over 6. So 30 degrees is just simply pi over 6. What about 60 degrees? Well, if you take 60 degrees, how many 60 degrees are there in 360 degrees? Well, there are 6 of those. So if we take, that'll give us our 360 degrees. So if we take our 2 pi, our 360 degrees, which is 2 pi, divide it by 6, we'll get 2 into 6 is 3, so we end up with pi over 3. So 60 degrees is pi over 3, 30 degrees is pi over 6. So they're the angles that we're going to talk about normally when we talk about radians. These are standard angles that we talk a lot about. There are loads of other angles, obviously, but very often we'll be talking about pi over 3 and pi over 6. Now, okay, we'll just talk about one other angle, and that's just 45 degrees. Well, if you take your x and y axis here, 45 degrees will look something like that. How many of these are there in 2 pi? Or 360 degrees. Well, we've got 1 here, 2 here, we'll have another one here, another one here, another one here, 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 here. So the 1, 2, 3, 4, 5, 6, 7, 8. There are 8 45 degrees, so 45 degrees times 8 will give us our 360 degrees, or 2 pi. So if we divide 2 pi by 8, we get 2 into 8, which is 4. That gives us pi over 4. So 45 degrees, our 45 degrees here, is pi over 4. So again, just to recap, we have 30 degrees being pi over 6, we have 60 degrees being pi over 3, and now we have 45 degrees being pi over 4. Okay, so these are our standard angles. Now, if we want to find the sine, cos, and tan of these particular angles, how would we do that? Well, let's have a look. Kind of a standard way of working these out is, let's say we'll draw a triangle like this. Okay, so I'm going to draw an equilateral triangle. An equilateral triangle. And we're going to call this side 2 units, 2 units, and 2 units in length. Okay, so this will be 60 degrees, this will be 60 degrees, and this here will be 60 degrees. So what I'm going to do then, I have one of our standard angles here, which is 60 degrees. Now I'm only going to talk about 60 degrees and 30 degrees in this particular case. So let's just divide that in half. So I'm going to divide that in half down the middle here like this. So what will that give me? Well, that will give me a 30 degrees here. That's perfect, that's what we want. And we have a 30 degrees here. Okay, so now I've set up my triangle. Just another couple of measurements. This will be 1 unit here, and this will be 1 unit. We've divided this 2 units into 1 and 1. So let's have a look at sine, cos, and tan of 60 degrees and 30 degrees then. What I'm going to need to do here as well, by the way, is just work out the length of this side here. Now, if you notice, I've divided this into 2 right-angled triangles. So I can just very easily work out the length of this side here by using Pythagoras' theorem. So we have, if I just take that side out here, or that triangle rather out here, I'll have 1 here. The hypotenuse is 2. I've got to try and work that one out. This is my right angle here. This will be 60 degrees here, and this will be my 30 degree angle here. Just to work this side out here, I'll use the theorem of Pythagoras, so we'll call it x. So it's just simply x squared plus 1 squared will give me 2 squared. So in other words, x squared plus 1 will give me 4, or x squared will give me 3, so x will give me square root of 3. So this side here, or this side here, is root 3. So this side here then, we're going to call that root 3, the distance from here to here. So now I have everything I need to work out sine, cos and tan of 60 degrees and 30 degrees. So let's just write those out. Let's see. Okay, so we want, first of all, let's say we'll deal with 60 degrees first. So let's take sine of 60 degrees. Well, we know 60 degrees is pi over 3. So the sine of 60 degrees, or the sine of pi over 3 here, is going to be, sine, as we know, is opposite over hypotenuse, the opposite over the hypotenuse. So let's look at this is our 60 degrees here. The opposite is root 3, and the hypotenuse is 2. So the sine of 60 degrees, or the sine of pi over 3, is just simply root 3 over 2. What about the cosine, or the cos of 60 degrees, or pi over 3 rather? So the cosine of 60 degrees, we know that that's the adjacent over the hypotenuse. So here's our 60 degrees. The adjacent is 1. And that's going to be over our hypotenuse in this case, which is the longest side here, which is 2. So the cosine of pi over 3, or the cosine of 60 degrees, is just simply 1 over 2. And the tan then, we might as well do that one as well. So the tangent, or the tan of 60 degrees, or pi over 3, is the tan is the opposite over the adjacent. So the opposite, here's our 60 degrees, the opposite is root 3, and the adjacent is 1, so it's just over 1, so it's just simply root 3. So the tan of 60 degrees is root 3. We can apply the same procedure to 30 degrees. So the sine of 30 degrees, again, that's just going to be pi over 6 in this case. So the sine of 30 degrees, or pi over 6, is, again, it's opposite over hypotenuse. So if we take our 30 degrees here, the opposite is 1. So it's going to be 1 over the hypotenuse, which is 2. So the sine of 30 degrees, or the sine of pi over 6, is 1 over 2. The cosine of 30 degrees, or pi over 6, is going to be, again, it's adjacent over hypotenuse. So that's, here's our 30 degrees. The adjacent this time is root 3. So that's going to be root 3 over the hypotenuse again, which is 2, so root 3 over 2. So the cosine of pi over 6, or the cosine of 30 degrees, is root 3 over 2. And the tan then is going to be the same as here. It's going to be the opposite over the adjacent. So their tan of 30 degrees is going to be opposite over adjacent. So the opposite is 1. So that's going to be 1 over our adjacent, which is root 3. So tan of 30 degrees is 1 over root 3. Okay, so that's sine, cos and tan of 60 degrees and 30 degrees. 45 degrees, or pi over 4, it's fairly straightforward. If you take, 45 degrees is going to look like this, roughly. You've got pi over 4, or 45 degrees here. It's going to, let's say it's 1 unit out here, 1 unit up here. Remember, 45 degrees, the adjacent and the opposite will be the same length. So it could be 2 units out, 2 units up. It could be 20 units out, 20 units up. But they'll be the same. Let's just say it's 1 and 1. That will give us, by Pythagoras' theorem, by the theorem of Pythagoras, that's root 2 there when you work it out. So if we look at 45 degrees, the sine of 45 degrees, or the sine of pi over 4, is going to be the opposite over hypotenuse, which is 1 over root 2. The cosine of pi over 4 is going to be the adjacent over the hypotenuse, so that's going to be 1 over root 2 as well. And the tangent, or the tan of pi over 4, or 45 degrees, that's going to be 1 over 1, which is just 1. So that's the sine, cos and tan of 45 degrees, 30 degrees and 60 degrees. Okay, so let's just look at one last thing when it comes to the unit circle, and that's going to be well, let's just have a look at it first. We'll draw a quick unit circle here, and we'll draw the two axes here. Now this is our x and y axis. So this is going to be our unit circle. In other words, the radius of this circle is 1. So the distance out here is 1. So this is going to be 1, 0. This here is going to be 0, 1. This point here is going to be -1, 0. And this point here is going to be 0, -1. Okay, so this is our unit circle. Now if we take a line out here like this, okay, this point here, if we drop a triangle down there, I'll just cross that out there, this point here is going to be xy. So that's going to be xy. In other words, we're going to go out here, that distance x, and we're going to go up along here, that distance y. So we go out x and up y. Now remember, this is a unit circle, so that distance there is going to be 1. The radius is 1. Now if we just look at the sine and the cos of this angle here, theta, we'll call it theta. That angle there is theta. So if we take the sine of that angle there, theta, the sine of that angle is going to be opposite over hypotenuse, which is y over 1, which is just y. In other words, y is sine theta. Let's look at the cosine, the cos of theta. That's going to be the adjacent over hypotenuse. That's going to be x over 1, which is just x. So in other words, what we've discovered here is that another name for x here is cos theta, and another name for y here is sine theta. So in other words, instead of writing x and y here, we could have just written those coordinates as cos theta, sine theta for the unit circle. So this coordinate here is xy, or it's the cos of the angle as our x component, and the sine of theta, the sine of this angle, for our y component. And that goes for each of these 4 angles that I've drawn here, or each of these coordinates that I've drawn. In other words, if you take 0 degrees here, or 0 radians, the cos is going to be the first coordinate here of 1, is 1. So in other words, the cos of 0 is 1. The sine of 0 is going to be the second number here, the y coordinate, which is 0. So the sine of 0 is going to be 0. If we look at 90 degrees here, or pi over 2, the first coordinate here is 0. So in other words, the cos of 90 degrees is the first coordinate. The cos of 90 degrees, if our angle is 90 degrees, the first one here is going to give us the cos of 90 degrees. So the cos of 90 degrees is 0. The sine of 90 degrees then is going to be the second one here, which is 1. If we take 180 degrees here, or pi, the cos is going to be -1. The sine of pi, or the sine of 180 degrees, is 0. And if we take 270 degrees, again, the cos of 270 degrees, or the cos of 3 pi over 2, is going to be the first coordinate here, which is 0, and the sine is going to be -1. Now, if if in the case this is not 1, let's say we'll call it or, for argument's sake, then our coordinates will be or cos theta and or sine theta. So if the radius is 5, it'll be 5 cos theta and 5 sine theta, and so on. Now finally, just to look at this thing here. This gives us the entire circle again, and it shows us all the angles in degrees and radians. So if you have a look, we have 0 degrees here. This is a unit circle again, so this is 1, 0. Here we've got 30 degrees, which is pi over 6. The cos of pi over 6 is √3 over 2, and the sine of pi over 6 is going to be the second coordinate here, which is 1 over 2. 45 degrees is pi over 4. This cos of pi over 4 is √2 over 2. Or if you have a look at that, in fact, √2 over 2 root 2 over 2, that's just the same as root 2 divided by root 2 times root 2. Remember, root 2 times root 2 is 2. So if you divide, you get 1 over root 2. So in fact, this here can be written as 1 over root 2, and this here is 1 over root 2. If you take 60 degrees here, that's pi over 3. So the cos of pi over 3 is the first coordinate here, which is a half. And the sine of 60 degrees is root 3 over 2. And so on. Now, if you look at these angles here in the second, third, and fourth quadrants, if you take 120 degrees, so we'll take 120 degrees here, that's actually twice 60 degrees. So it's going to be twice pi over 3. So it's going to be 2 pi over 3. If you take 135 degrees, that's 3 times 45 degrees. You've got 45 degrees here, you've got another 45 degrees here, and you've got a 45 degrees here. So it's 3 of these pi over 4, so it's 3 pi over 4. It's the same with 150 degrees. 150 degrees is going to be 5 times 30 degrees. So it's going to be 5 times pi over 6, which is 5 pi over 6. And so on the whole way around. You've got 210 degrees. That's going to be 7 times 30 degrees. So that's going to be 7 times pi over 6, which is 7 pi over 6. 225, that's going to be 5 of these 45 degrees, so it's 5 pi over 4. 240 degrees, that's going to be 4 of these 60 degrees, so that's going to be 4 pi over 3, and so on. You've got 5 pi over 3, 7 pi over 4, and you've got 11 pi over 6, and so on. Okay, so that gives you all the angles in degrees and radians and the cos and sine of each. You'll also find these in your mathematical tables. You'll have the degrees along the top, you'll have the radians, and then you'll have the sine, cos and tan listed for each. It'll also give you a unit circle, not in as much detail as this, but it'll give you these coordinates here. 0, 90, 180, and 270 degrees. So that's about it for radians for the moment.